For my alternate midterm submission, I've selected a problem that goes as follows. The driver of an SUV with mass 1,700 kilograms isn't paying attention and rear-ends a car with mass 950 kilograms on level ground at a red light. On impact, both drivers lock their brakes. The SUV and car stick together and travel a distance of 8.2 meters before coming to a stop. How fast was the SUV traveling just before collision? The friction coefficient between road and tires is 0.72. Okay, to start this problem, what we're going to do is draw a diagram. It's going to be in two parts and consist of before the collision and after the collision. So the first part is we have the SUV and we have the car. Now we're going to label this point 1. The information that we were given means that we do not know the initial velocity of the SUV, that the mass of the SUV is equal to 1,700 kilograms. The car's velocity is 0, and the mass of the car is 950 kilograms. After the collision, we see that the SUV car system travels a distance of 8.2 meters. Now, the information we have for this is we do not know the velocity of the system at point 2, but we do know that the total mass of the system is equal to 2,650 kilograms at both point 2 and point 3. But the velocity eventually becoming 0 when they stop and maintaining the same mass. So now we will use conservation of energy from point 2 and point 3. Minus the weight. Okay, so from here, we will plug in the values that we know. M total velocity at point 2 squared plus the M total gravity H2. Oh, and quick note, height is going to be 0 in both of these because it is a horizontal system and nothing is moving in the vertical direction. So as long as 1/2 M total velocity at point 3 squared plus M total QH minus the weight. So from here we will simplify, so we can get rid of that, and we can get rid of that, and we are left with 1/2 velocity 2 squared plus 0, since our height is 0, equals 0, since the velocity at 3 is 0, plus 0 again, because height again is equal to 0, and it's going to be minus the weight, which will be the coefficient of friction times gravity times the distance multiplied by cosine of 180 degrees, since we're on level ground. All right. Further simplify. We are left with 0.72, 9.8, a distance of 8.2 meters, and the cosine of 180, which is -1. You can also multiply that on both sides, which, taking into account for sig figs, and entering all this into a calculator, we are left with 100 16 meters per second squared. You take the square root of that, gives us 10.8 meters per second squared. Okay, now we can use that information to find the initial velocity of the SUV. Now for this, what we'll use is conservation of momentum. So we have 0.1 equals 0.2, and since this is in the horizontal direction, we will use P1x equals P2x. Alright, so that will give us the mass of the SUV times the velocity of the SUV plus the mass of the car times the velocity of the car equals mass total of velocity 0.2. Now, substituting in our values that were given, we have 1700 kilograms. We are looking for the velocity of the SUV plus 0, because the velocity of the car initially is 0, equals the mass total of the system times the velocity after collision, which is 10.8 meters per second. Sorry, a little difficult to do this while holding a phone, which will give us 1700 kilograms multiplied by the initial velocity of the SUV. Kilograms meters per second, which will finally give us, after dividing, the initial velocity of the SUV, which is 17 meters per second. I know this video ran a little longer, but I'm just trying to be thorough. I hope this explanation was sufficient, and if there is a problem with the video at all, please let me know. I will redo it. I know it's a little shaky. It's just kind of hard for me to do. Thanks.